Now, in the previous class, I had given some examples of how to predict the period, group, and block of elements. Okay. Now, today, before going to directly predicting the periods, groups, and blocks, I would like to first give you the rules for predicting the group, period, and block. Okay. So please pay attention. Okay. Number one, period. For period, for period, how to come to know the element belongs to which period? The principal quantum number.
Highest magnitude.
The principal, yes. The principal quantum number. Number of the valence shell. The principal quantum number of the valence shell represents the period to which an element belongs. To which an element belongs. Okay. For example, if I take sodium, its atomic number is 11. Okay. Now I'll write down the electronic configuration: 1s2, 2s2, 2p6, and then 3s1. The valence electron is this one. Okay, so the principal quantum number is over here 3. Okay, its principal quantum number is 3. So which period? So it is sodium is third period. Did you get it? The period one? Okay. So to get the period, you should look at the principal quantum number of the valence shell to which an element belongs. Okay. Now, let us go to the next one. That is for block. Number 2, for block. For block, remember the subshell S or P or D or F, the subshell in which the differentiating differentiating in which the differentiating electron enters, and this represents the block to which the given element belongs. For example, if you look at scandium, okay, scandium, its atomic number is 21, and its electronic configuration, if I write down, it becomes 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s2, 3d1. Okay. Okay. So just check whether I am correct with the above principle or not. Let's check this electronic configuration with respect to the above principle. I have taught you above principle in the previous class. After 3p comes 4s, then comes 3d. Correct, no? Is this correct?
Yes, sir.
Okay, so here the differentiating electron is entering which subshell? Which subshell? The differentiating electron is this one electron. It is entering which subshell? Is it D? Is it D? My question is it D? Yes. Is it entering
So
the?
I didn't understand.
What you didn't understand?
What are you talking about, sir? Which subshell?
There are subshells S, P, D, and F. These are called what? Subshells. Okay. In S subshell, there is only one orbital, S. This is a P subshell. In P subshell, there are three orbitals. This is D subshell. In D subshell, there are five orbitals. 1, 2, 3, 4, and 5. Are you getting it now? This is F subshell. In F,
Yes, sir.
there are seven orbitals. 1, 2, 3, 4, 5, 6, and 7. So these are the orbitals. So I'm talking about the subshells. S subshell, P subshell, D subshell, F subshell. Now, the differentiating electron in the case of scandium, which is also known as the valence electron, it is entering which subshell? Which subshell?
D.
So therefore, block. It is a D block element. D block element. So this is how you get the block. So we have understood how to get the period. Okay. We have understood now how to get the block also by taking an example of scandium. Okay. Now the most important thing, number 3, is to get the group. For group, for groups, to know the groups, there are three things to keep in mind. If it is a S block element, if it is an S block element, then the group is equal to simply number of valence electrons. Simply number of valence electrons. If it is an S block element, because we get the block here only, no? We get the block here only, no? Are you getting it? Sodium, it is S block element. So how will you get the group? Number of valence electron is what? How much? What is the number of valence electron? Tell me for sodium. What is the number of valence electron for sodium? Can you see over here? How many electron in the S subshell?
One.
1. That is what I'm
1.
speak. So for an S block element, the group number is equal to number of valence electrons over there. If it is an S block. Next, number B, for P block, for P block elements, group number of group or group number is equal to 10 plus number of valence electrons. 10 plus number of valence electrons. So for a P block elements, this is how you get the group number. Example, let's take any element from the P block. For example, let's talk about aluminium. Aluminium atomic number is 13. We write the electronic configuration: 1s2, 2s2, 2p6, then 3s2, 3p1. Are you getting it? 1s2, 2s2, 2p6, 3s2, 3p1. Okay. Now you tell me from here, this element belongs to which period? Tell me. It belongs to which period? This element
The
element.
first.
It is which period? Period.
1.
No. For the period, what did I tell you? The quantum number, no, of the valence shell, no. For the period, look at the quantum number. What is the quantum number of the valence shell? What is the quantum number?
3.
Yeah, so period it is 3. After period, what are you supposed to find out? Is it the block? Is it the block?
Yes, sir.
Yeah. Now for the block, what did I tell you? What do you have to look at for the block? The subshell in which the differentiating electrons
Valence
enters. Yes. So
P.
So,
it is P, no? It is P, no? Are you
yes,
getting
sir.
it? It is P.
Yes, sir.
Because the subshell in which the valence electron is entering is P subshell. So I write over here block is P. After that group, now group. Over here, to get the group, the formula is 10 plus number of valence electrons. 10 plus the valence shell is this one. Valence shell is 3s and 3p. So total how many electrons are there in the valence shell? 2 plus 1 is how much? How much? 2 plus 1 is how much?
So why we added the before one also? 3.
Which one? We are adding this
So
before one
3S.
Why we took 3s square also?
because see 3s and 3p. This is the valence shell, not the subshell. Valence shell. What is written over here? Number of valence shell electrons. Number of valence electrons, not the outermost only. Because this entire thing becomes the valence shell. This entire thing becomes the valence shell. Because principal quantum number is same. 3 over here also, 3 over here also. Are you getting it? That's why 10 from the formula 10 plus number of valence shell electrons. Number of valence shell electrons. So 10 plus 2 plus 1 is how much? It is 13.
13.
So the group is 13. Did you understand, Rohan? Did you understand?
Yes, sir.
Rohan? Okay. Now is this clear? How to get the groups for S block element? How to get the groups for P block
So
element?
can we try once for high atomic number?
Yeah, I will do. I will do. First, let me finish the rules. Okay. Then I'll go to the atomic number. Okay. Now, number C. Number C. Number C over here for D block elements. For D block elements. For D block elements. Number of group number is equal to, the formula is 2 plus number of n minus 1 d electrons. N minus 1 d electrons. Look at this. For d block elements, the group number is equal to 2 plus number of n minus 1 d electrons. So to get the group number for d block, example, I'll again come to scandium. Scandium atomic number is 21. Over here, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2, and then it is 3d1. Now for scandium, first get the period. Scandium belongs to which period? Tell me. Which period? Scandium belongs to
3.
which period? Is it period 3? Correct. Because over here 3. Scandium belongs to which block now? Tell me. Which block?
So D.
It is D. Because differentiating electron is here. It is D block. Now for the group. The formula is 2 plus n minus 1 d electrons. Okay. So add over here 2 plus n minus 1 means what? Your n is 4, no? N minus 1 is 3. So in the 3d orbital, how many electron is there? How many electron is there? Huh? Huh? It is 1. So n minus 1 d electron is only 1. So I put over here 1. So 2 plus 1 is how much? 2 plus 1 is how much? 2 plus 1 is how much?
3.
Isn't it
3.
3? So the group for scandium is 3. Okay, now I will go back to scandium, the periodic table, to check.
So what did you
Yes, tell me. Pardon?
So what did you say was
Tell me clearly. I cannot hear your
so
voice.
that N?
N.
So what is that N?
This N stands for the principal quantum number, the highest principal quantum number. So n minus 1 is 3, no? 4, this is 4 minus 1. Does it become 3? Does it become 3? Does it become 3? 4
Yes,
minus 1, is
sir.
it 3? That is the formula I'm giving. So to get the group for D block elements, 2, the formula is 2 plus n minus 1. N is 4 for the largest, highest principal quantum number, minus 1 is 3. That means I'm talking about the 3D orbital. And it has 1 electron. That's why I'm putting the 1 over here. So I'm getting 2 plus 1 is equal to 3. Now you check in the periodic table. Okay, over there, if you check in the periodic table, you will get the answer over here. For scandium, the group, I'll just go to the periodic table, yesterday's periodic table. Look at the periodic table. This is group 1, group 1, group 2, scandium. Look at this scandium. Is it group 3 now? Is it group 3? I'm asking the question, is it group 3? Nobody's answering.
Sir.
It is group 3. Okay, now let us come back. Now I have these 3 slides are very important. This one, and this one is very important. These 4 slides. To know the period.
Sir,
Yes. Yes.
the valence electrons are the electrons with the highest quantum number, so that quantum number n value.
Yeah, now differentiating electrons are the electrons entering the subshell. And the valence electrons are the electrons which are present in the valence shell. Over here, valence shell, it becomes, over here 4s, because this is the highest over here, no? The highest over here, no? You can see valence shell. And just below this 3D
Yes,
is
sir.
incompletely filled. It is only 1 electron, so we count this also. Okay, are you getting it? Now we come to the real examples in the next slide. Now we come to the real examples. Okay, now you also do, I'll also do. You also do predict. The question is, you also do in your copy, predict the period block PB and group. This is the correct order. Predict the period, block and group. Remember this. This should be the correct order you have to predict. First the period, then the block, and then only after that group, by following the rules which I have stated. The first element which I want to give you is, say, number 1. Have you heard of antimony? SB. SB. SB is called antimony.
Yes, sir.
It is called antimony. Symbol is SB. Now antimony, I will give you the atomic number. Atomic number is 51. Okay. Now, all of you, please write down the electronic configuration of antimony. I am waiting. I am also writing. You also write by following the above principle. I am also writing. You also write the electronic configuration of antimony. You also write. I also write. I start. Okay. It is 1s2, 2s2, 2p6, 3s2, 3p6. Okay, 3p6 is done. All of you. After 3p comes
Yes, sir.
what? After 3p comes what?
4s square.
Yes.
4s2.
4s2. Then I'm writing 4s2. Then after 4s2 comes 3d. Does it come 3d? 3d.
Yes, sir.
Yes, sir.
3d10. You write down 3d10. After 3d comes 4. After 3d comes 4. 4p6. Is it 4p6? After 3d? Yes? Is it 4p6?
Yes, sir.
After 3d?
Yes, sir.
Sir.
Then where is 4s then? 4s is done, finished. After 4p comes? After 4p6 comes
5s.
5. After 4p comes
S2.
5s. 5s2. After 5s2 comes what? 4d. 4d. I am following the above principle. 4d has 10 electrons. After 4d comes what? Does it come 5p? Does it come 5p? Check in the above principle. 5p. Now just check the total. 2 plus 2, 4, 4 plus 6, 10, 11, 12 plus 18, 20, 30, 36, 38, 48, 48, 49, 50, 51. So 5p
3.
will have 3 electrons. Did you understand now? Did you understand how to write the electronic
Yes, sir.
configuration by following the above principle? So that's why I told you last time. Please learn it, okay? Please learn it. For the time being, you can have a look at the above principle, which you have noted down in your text, in access copies or your textbooks also. On your textbooks, you'll find it on page number old textbooks 128. Okay. Now first get the period. First get the period. Which period does antimony belong to? Which period? Which period does antimony belong to?
5.
It is period 5. It is
5.
period 5. See, 5 is there, no? 5. So I write over here 5.
Yes.
After period, get the block. Get the block.
P block.
Now this element is antimony, the electrons, differentiating electrons entering the p subshell. So it is p block. It is a p block element. Okay. And then p is done, b is done, g is also done. G is about to be done. So now get the group. Group.
13.
Now get the group. What is the formula for p block? I have told you that time. Formula
10
for
for
p block.
10 plus valence electron.
10 plus
10
10
plus
plus
n.
Valence electrons.
number of valence shell electrons. Number of valence shell electrons. Correct, no? So I write 10 plus.
Yes.
Yes,
Which is
sir.
the valence shell? Which is the valence shell? This one and this one. No?
5p and 5s.
Yes. 5s and 5p, no? Valence shell, no? So what is the total number of electrons?
Yes, sir.
2
15.
plus
10
2
plus 5.
plus 3. 2 plus 3, no? Is it 2 plus 3? So it is coming 10 plus 2 plus 3 is 15. So what is the
Yes,
group?
sir.
What is the group of antimony?
15.
What is the group for antimony? It is 15. Now let us check our answers by going back to the periodic table. Yesterday's periodic table. Antimony SB. Okay. Over here. Now antimony, nitrogen, phosphorus, arsenic, antimony. Have a look. Antimony. Did you see antimony? Antimony is here. SB. Can you see on the screen? And what is the group? What is the group? 15. Are we correct? Are we correct, my dear boys? Did you get this? Now we will go to a higher atomic number.
Yes, sir.
We must climb steps slowly and slowly, not straight away do difficult things. Okay, now we'll go to the next example by taking a higher atomic number. By taking a higher atomic number, but let me introduce one more slide over here because slides are over. Okay, now the next element which I would like to do is let me select 80, 81. Let's take 86. 86 element. Example number 3. I'll write. Okay. The element is Rn. Have you heard of Rn? Radon.
Radon.
Radon. Its atomic number is 86. Atomic number is 86. Is that clear? This is the maximum atomic number which is normally
Yes, sir.
asked for class 11 science. Okay, in class 12 science also. If you go in higher chemistry, then you can talk about something more than 90 or more than 100 up to 120. But if I teach you till radon, that is sufficient because questions are never asked. I have never ever seen any questions which have been asked beyond radon, frankly speaking. Now, you also write down the electronic configuration for radon. You also write, I will also write. Okay.
Sir,
Yes.
so like if it enters D electron, it's 2 plus n minus 1d. No, but if it enters F electron, F shell, then
Then I will tell you for that also. I'll tell you for that also. If it is entering n minus, if it is entering that what you call f orbital, then it will be n
F
minus.
subshell.
That time you have to follow this. That time you have to follow this. Wait, okay, I'll show you. Then it has to be this one. If it is entering S F subshell, no, then it has to be n minus 2 F orbital F subshell, n minus 1 D orbital, number of electrons you have to add, and n S orbital. Are you getting it? In the case of electrons entering F orbital, the questions with regard to F orbitals has not been asked. If it is asked, then you can follow this rule: n minus 2 F electrons, n minus 1 D electrons, and n S electrons. Okay, for F orbital. But as far as I know, over the last 10 or 11 years, the questions for predicting for F, what you call block elements have not been asked. Okay, so they'll ask you questions for S block or D block prediction or P block with regard to the period, group, and the block. Okay, now come to the present question. Is that clear, Rohan?
Yes, sir.
Okay, so I think it was Rohan only, no? Now let us write down the electronic configuration of this element radon. I also write, you also write, okay? Is that okay? Is that okay? So you write, start writing.
Yes, sir.
Radon, you start writing 1s2, 2s2, 2p6, 3s2, then 3p6, 4s2, then I'll get 3d10. After 3d10, again 4p6, then 5s2, 5s2. Okay, then comes 4d, 4d10. Okay, after 4d10 we have 5p, no? After 4d we have 5p, so 5p6. After 5p we have 6s, 6s2. We have 6s2. Then after 6s we have 4f, 4f. It will have 4f will have 14 electrons. Okay, after 4f we have 5d, 5d10, 5d10, 5d10. Okay, then after 5d10, 6s2 is done, 6p is also done, 6p, just check 6p is done. After 4f comes
Not done 6p.
6p. Now wait till 6p. Now just add the total. 2 plus 2, 4, 4 plus 6, 10, 11, 12 plus 18, 20, 30, 36, 38, 48, 54, 56, 66, 70, 80, 80, and then 6 over here. 6p has to have how many electrons? 6 electrons, no? 6 electrons.
6.
It is a noble gas. Is it a noble gas?
Yes, sir.
Is it a noble gas, my dear boys? Okay. Now,
Yes, sir.
first thing you're supposed to remember is P, B, G, no? What does P stands for? Period. B stands for the block and G stands for the group. So follow this order. So the first thing is you have to find is period. So which period? Which period? Which is the maximum highest principal
6.
quantum number? 6. It is 6. Did you see? It is 6. So I write period 6. After that block. After that block. Which block? The
P.
valence electrons.
block.
The valence electrons are entering which? Which subshell? Which subshell?
P
So
block.
P.
P. So P over here. I
P.
write over here P. After that, it is a P block. So I write this way, P block. Okay. After that, group. Now group. Now for a P block element, what is the formula I gave you? For a P block element, 10 plus
10 plus number of
10
valence
plus
electrons. Number of valence electrons.
of valential electrons. Valential electrons. Okay. Now 10 plus number of valential electron is it 2 plus 6? The valential is 6s and 6p, no? This
Yes, sir.
valential
6x square and 6p6.
it is made up of S subshell and P subshell. The S subshell and the P subshell are combining to form this valential. So 2 plus 6, no? Is it 2 plus 6? Yes or no?
Yes,
Yes,
sir.
sir.
Speak. So 10 plus 2 plus 6 becomes how much? Does it become 18?
18.
18. So the group number for radon is 18. Now Let us check our answer. Let us check our answer by
Sorry.
going back to the periodic table. Radon over here. Look at the periodic table. Radon is
Correct.
here. Radon is over here. Okay. Radon is over here and the group is 18. Its period. Period for radon is over here. Period. What is this period? 6, no? Period 6.
Yes,
Is
sir.
it? And it is an S block element. It is an what block? Not an S block, P block element. It is a P block element. How? How? Okay, look at this. Look at this figure over here. This figure over here. This is a P block element. All the noble gases except helium, they are what? P block elements. Am I clear, my dear students? Am I
Yes,
clear?
sir.
I'm asking
Yes,
again and
sir.
again. Okay. So since the prediction today, I have given one full period to explain you how to predict the P, B and G. P, B and G. That means period, block and group of elements from the atomic number. It is very important that you are given the atomic number. If the atomic number is not given, then you will not be able to write down the electronic configuration. And if you are not being able to write down the electronic configuration, then you will not be able to know which period, which block, and which group. Are you getting it? But please keep in your mind, please keep in your mind, while writing the atomic number, you can follow the above rule. If you don't want to follow the above rule, never mind. If you don't want to follow the above rule, then you can simply follow the mathematical rule, English number mathematical rule, and simply write 1s2, 2s2, 2p6, 3s2, 3p6, then 3d10, after 3d10, 4s2, then 4p6, then you can write on 4p14, after 4p14 you can get 5s2, then you can write 5p6, then you can write 5d10, then you can write 6s2, 6p6. This way also you will get the answer. If you write the electronic configuration without following the above principle, the increasing order of energy, even in this way also you will get the answer. Correct answer. You will not go wrong. Here you can locate directly which is the valence shell. The valence shell. It is principal quantum number is 6. Okay. Are you getting it? And the period is 6. Period is 6. Block is P. Block is P. And the group is 10 plus 2 plus 6 electrons. So this method is also correct. If you do this method in the examination, it is also correct. Did you understand, my dear boys? Did
Yes,
you
sir.
understand? Okay, now I am giving one for you all to try. I am giving one more for you all to try. Okay. Now, on the next slide, we have some 2 minutes left. In that 2 minutes, you can complete it easily. The atomic number of that element which I am going to give you is Z is equal to 82. Within the next 2 minutes, complete this. Complete this within the next 2 minutes. Atomic number Z is equal to 82. Come on, you start. You start, all of you. You start. You start and tell me the period, block, and group. Atomic number, what do you call? 82. Atomic number 82.
So done.
Atomic number 82. Yes. Now tell me, Ron, is it Ron? Ron finished?
Yes, sir.
Okay. So atomic number 82, period, tell me the period. Period
6.
6. Tell me the block. Tell me the
P
block.
block.
P block. Wonderful, wonderful. It is the P block. Now tell me the group.
14.
It is group 10 plus
14.
2 plus 2. That is coming to 14. Did you understand now? Now
Yes, sir.
this element belongs to group 14. That means it belongs to which family? Carbon, silicon,
Carbon family.
germanium, tin, lead. Carbon is period 2, period 3, period 4, period 5, period 6. So the answer is the element is identified. The element is, I'm talking about lead. I'm talking about
Solid.
lead. Okay. So now, my dear boys, you must have a lot of patience. When you give time today evening, practice this prediction of elements just by taking randomly atomic numbers from 1 to say 86. Okay. Higher elements you practice on your own by writing the electronic configuration randomly without following the above principle. But if you follow the above principle, it is good for your only, because you will come to know which orbital, which subshell is lower in energy, which one is higher in energy. Am I clear? So today you have
Yes,
become
sir.
today most of you have become better than me in predicting the what do you call P, B, and G of the elements. P means period, B means block, and G means group. Am I clear? Are you confident now, boys?
Yes, sir.
Okay, since you are confident, so I would like to end my class here only. But hang on, stay over there only, because I need to record your attendance also. Then you may
Excuse
leave.
me, sir.
Yes.
Yes, sir.
Yeah.
Sir,
Somebody. Yeah. Somebody
sir,
asked you.
this atomic number when you are writing, no, then
Uh,
it is becoming too big, no.
yeah. Yeah.
Sir,
So
can we write this in a condensed formula?
yeah, you can write content. That is very good. If you write content, that is wonderful, man. That is wonderful. If you can write contents, it is much better.
Okay, sir.
Are you getting it? You know how to write contents for
Okay,
like
sir.
by using the noble gases in square brackets. By
Yes,
using
sir.
what? By using the noble
Yes, sir.
gases. For example, I'll show you this one only just now only. Just hang on. Just don't go away. Like for example, if you look at lead, this one only, this example, if you look at lead, no, lead belongs to sixth period, no? Lead belongs to which period?
Yes, sir.
It belongs to sixth period.
Sixth
Now,
period.
what is the what do you call this? In the sixth period, in the sixth period, before 82, there are 81 elements. So you can write xenon, no? Xe. Can you write
Xenon.
xenon? Xenon, and then continue with 6s, that is cesium, and then land up to 6s to 6p2. Because xenon is how? What is the atomic number? Xenon atomic number is 54. And xenon atomic number 54 means it is entering 5s2 5p what 6. After 5s2 5p6, then you continue further. After 5p comes which one? After 5p comes which orbital? Tell me. Huh? After
6s2.
5p, yes.
6s.
6s.
After 5p comes, you can write 6s and then go to what do you call 6p. Okay, then you will get the what do you call in this correct manner over here, 6s over there and then 6p, and then you get the correct location. But don't forget to put the f orbital also, because the f orbital, it contains 14 electrons. Then only your total will become 82. Okay, but nevertheless, like I would request you to get into the habit of writing the entire thing. Writing the entire thing. It is good to write things in shortcut, but for this prediction, no, get in a habit of writing the entire thing, because in that way you will not go wrong anywhere. You will not go wrong or make mistakes anywhere. Okay, because if you miss an orbital somewhere, again add it, you'll have a problem. Okay, so I would like to stop my class here only. Hang on over there for some time. Okay, then I will record your attendance. What class you have next?
After lunch break.
After lunch break?
Break.
Huh? After lunch break, sixth
Body.
period. Huh? Biology?
Second language.
Okay, second language. Okay. So I am downloading the attendance list. It is downloaded, only 37 boys remaining boys, they are having a bad time, going to have a very bad time, because now the promotion depends on this online classes. Because I will not correct the answer scripts of the boys those who are regularly absent. I'll simply, because yesterday's meeting, our principal has directed us not to do so. Okay, he has told, okay, give them absent. We will not promote them to higher class, because this online attendance is very, very important. Okay, if the council happens to demand for an attendance, then this is what we'll provide. Okay, so now you may leave the class. Thank you so much. Have a nice day.